So one of the things that we do with factoring is we solve quadratic equations. And there are other ways. When we talk about quadratic equations, we want to remember that there are, remembering of course what quadratic means, of course the prefix 4, there are 4 ways to solve quadratic equations, and they have the general form of a trinomial. And you'll notice that it is a leading exponent of 2. Now, it says form of, so when we do quadratic equations, they can look a little bit different than this. There can be binomials, we can have 4-term polynomials, so this again is a general format. One of the big things that we have here, though, is that it is set equal to 0, and that is always the case. And of course we can't have any negative exponents, so we've got to be careful of that. Also, the leading coefficient is generally greater than 1, so if it's negative we do have to do some work with that. Now, one of the primary things that we have to deal with is that principle of zero products. And the principle of zero products is pretty straightforward. If A times B is 0, then we know almost intuitively that A or B, and it could be both, has to be 0. So when we start thinking about factors, if we have x plus 3 and x minus 2 is equal to 0, well, that means one of these has to be equal to 0 for it to be equal to 0. So as we start setting up our quadratic equations, we really do have to remember this is a really important feature here. Without that zero product principle, it doesn't work. So when we start looking at solving a quadratic equation by factoring, of course the first thing we do is put it in proper order. Almost always we put it in descending order. We make sure that that polynomial is set equal to 0. If we don't have it equal to 0, it doesn't work. Then we simply factor the polynomial, as we have been practicing the heck out of, and then we set each factor that contains a variable, let's be clear there, equal to 0, and then we solve each of the new little equations. The solution, after we've done all that, each of those is a solution to that quadratic equation. So each one consists or creates the set that is a solution to that quadratic equation. So I know that sounds nice and complex, but it really isn't. So here we've got a quadratic equation. We know it is because if I multiplied x times x, I would have x squared. So that's one of the things that tells me it's quadratic. We have that set into equal to 0, so that's good news. This is already in factored form, so we don't have to do any work. All we have to do is take each factor. I'm going to leave it in parentheses just for effect. Now remember that you don't need the parentheses, so I'm going to rewrite it without the paren. So it's just x minus 2 equals 0. And remember, all we have to do to solve that, we add 2 to each side. So we're just solving our basic linear equation. So x is equal to 2. And here we're going to subtract 3. So x is equal to negative 3. So x is equal to 2 and negative 3. Let's go ahead and look at the next one. Now this one is not in factored form, so we have to do work. So the first thing we do is we sort of go through our checklist and we say, all right, this thing is in proper order. It is definitely quadratic in nature because we see that exponent, and it's set equal to 0. So this is nicely set up for us to solve using factoring, solve this quadratic equation using factoring. So the first thing we're going to do is work on factoring our polynomial, and that has to be what we do first. Now as we do this, I'm going to use what I would consider to be the quickest method. And you'll notice that I just bring that 0 along with. So basically I see that this is a prime number, so I know it's got to be 2 and 1. And now I just have to decide which factors I want to try to put in there. And it may take you a little bit more time, and that's fine. It's not supposed to be quick for you because you're just learning it. So I'm going to go ahead and choose 3 and 4. Signs are the same, so I'm looking for things that add to 11. This negative tells me both should be negative. So now when I do my little check, negative 3x, negative 8x, that's negative 11x. So I've got my polynomial properly factored. So now I'm going to take each factor, set it equal to 0. So I've got 2x minus 3 equals 0, and x minus 4 equals 0. Solve each of these. So x is is 3 halves, and now I'm going to add 4 here. And x is 4. So those are my two possible solutions. Now this one is also in proper form. We see that we've got a leading exponent that's bigger than 1. So we're going to go ahead and use this same method. And now we are going to go ahead and use factoring by grouping, since we see that it is a 4-term polynomial. My greatest common factor here is x squared divided out. The minus always comes with. There's no greatest common factor, so it's 1. And we divide both of these by negative 1, and we're left with x plus 8. Now I bring my new greatest common factor out, and the leftovers go in here. But remember, one of the things that I'm always doing is seeing if anything else can be factored further, and this can be. So I'm going to go ahead and factor that further. We see it's the difference of squares. So x plus 1, x minus 1 equals 0. So now I've got 3 factors. I'm going to take, again, each factor, set it equal to 0. And solve. And notice that I'm using the same skills that I used at the very beginning of this class, solving basic linear equations, and there are my solutions. And you'll notice that I have 3 of them. So one of the things that I really want you to take note of is, here we see that we've got a 3 exponent. On the ones that we just did, here I had a 2 exponent. When I had that 2 exponent, I had 2 solutions. Now that I've got a 3 exponent, 1, 2, 3 solutions. Now this isn't something that always happens, but it is something that happens almost always. There are a few exceptions to the rule, and it's basically when we have like a squared factor or something like that. For the most part, the leading exponent is telling you how many solutions you're looking for. You don't always have them, but that's always what you should be looking for. That's what you should be thinking. So now we've got another one, and here we see we've got a greatest common factor. So we pull that x out, and we go ahead and factor that out. And now we see that we've got a trinomial, leading coefficient of 1, so that means I'm just going to do my little double paren and do a little x and an x. And now I know that I am looking for factors of 56 that add to 15. And of course that's 8 and 7. And the signs, that second sign always tells me the signs are the same, and the first one tells me what the sign is, so these are both negative. So now I see again, there's my 3 exponent, and here I have 1, 2, 3 factors. Set each of those factors equal to 0. If it's got a variable in it, it needs to be set equal to 0. And now I solve each. Well, this one I don't have to do anything to, so x equals 0. 0 is one of my solutions. 8 is another solution. And 7 is the third solution. Let's go ahead and do this next one. Here I see that I've got a greatest common factor again, but this time it's a number. So let's pull that out. Now I look at this, again, look at that, and I see that I've got an exponent of 2. But I want you to notice here that this is a constant. There's no variable in there. So we can't set a constant equal to 0 because 5 does not equal to 0. And I'll go ahead and show you that in a minute. But we do want to make sure that we understand we're looking for 2 solutions. And we'll see that even though we've got a greatest common factor, we're still just going to have 2 solutions. I'm going to bring that 5 with me so I don't forget it. This is x plus, and of course I'm getting that from the idea that I've got a leading coefficient of 1, so it's just x and x. Signs are the same, both positive. And what are the factors of 1 that add to 2? Well, that would be 1 and 1, folks. Now, I'm going to rewrite this because you'll notice that this is the same. So that's a little bit prettier. I'm going to go ahead and go back to this and say, all right, well, using our same theory that we take each factor and set it equal to 0. 5 equals 0, x plus 1 equals 0, x plus 1 equals 0. Well, 5 equals to 0, that doesn't work. That can't happen. It's a false statement, so that's not going to give me a solution. Now we're going to subtract 1. So x is equal to negative 1. And again, x is equal to negative 1. And we see that that's exactly the same answer. So in this particular case, we actually only have one solution. And that is because we see our greatest common factor is numerical. So again, 5 will never be equal to 0. And we also see that this factor is squared, which means the solution is exactly the same. So in this case, this is one of those interesting exceptions that happen. We only have one solution here. Again, you can do it this way to see the answer, but if you write it this way, it's usually easier to see that you only got one solution. Okay, so I want to do one more example for you here because this is one more thing that can happen. And we look at this, and again, we can see that this is an exponent. So we see that it's quadratic. The equation, and we know it's an equation because there's an equal sign, is quadratic. But the problem is that it's not set equal to 0. Well, that's fine. All we have to do is make it so. So we're going to subtract 36 from both sides. So we have x squared minus 9x minus 36 is equal to, and of course, that's equal to 0. So now I've got a trinomial with a leading coefficient of 1. So that's x and x. And then we go to the factors of 36 that subtract to 9, and that would be 12 and 3. Signs are different. Bigger product is negative. And again, the next thing you should do is multiply this back and check. I just don't want to spend the time on the video to do that. Now we're going to take each term, set each term equal to 0, and solve. One solution. And a second solution. So we have 2 solutions, and our exponent was 2, so that would be what we would have expected.